Hello students, welcome back to my YouTube channel. In this video, I am going to discuss about force acting on a charged particle moves in combined electric and magnetic field. Okay, combined electric and magnetic field. Okay, clear? Okay, this video is only for NEET and JEE students. Okay, first we will do a quick review about the theory and formulas. Okay. If a charged particle moves in a combined electric and magnetic field, it will experience electric force, that is electrostatic force, because if a charged particle have an electric field, it will interact with the external electric field, so it will experience a electrostatic force. Okay, if Q charges moves in a electric field of E, it will experience a force, that is F is equal to QE, and if a charged particle moves in a magnetic field, it will produce a magnetic field. That magnetic field interact with the external magnetic field, it will experience a external force, that F is equal to Q into V cross B. Okay, clear? This is the thing. So there are two forces are acting on a charged particle. So the net force F net is equal to what? The vector sum of the two forces, that is Fe plus Fb. That is how much you get? Q into E plus V cross B you will get. Okay, this is the net force acting on a charged particle moves in a combined electric and magnetic field. Okay, now we will see velocity selector. Velocity selector. What is the principle of velocity selector? Okay, velocity selector, the principle is the charged particle moves in perpendicular in cross field. That means velocity, electric field, magnetic field, both are perpendicular. Okay, that means I am going to take E is equal to, in a region electric field is equal to EJ, and magnetic field I am going to take B is equal to Bk, and velocity V is equal to Vi. Okay, this is the thing. Okay, and the charged particle is Q. We can draw the diagram like this. This is a negative plate. This is a positive plate. Okay, so the electric field is acting in which direction? This direction. So that is in the J direction. What about the magnetic field? Magnetic field is in the K direction. So I can draw like this. So magnetic field. Okay, and what they given? The charged particle is moving like this. So Q is moving with the velocity V. This is the velocity direction. This is the B direction. This is the velocity. So what about the electrostatic force? That is electrostatic force is equal to how much you will get? That is Q into EJ you will get. Okay, that means electrostatic force is acting in this direction, that is Fe. Okay, what about the magnetic force? Magnetic force is equal to, that is Fe is equal to Q into Vi cross Bk. That is, what is I cross K? I cross K is equal to J. So we will get Fb is equal to what you will get? Fb is equal to, you will get it as Q into Vb, and sorry, I cross K is equal to what? Minus J. Okay, because if you will be taken the clockwise direction, that is I, J, K. Clockwise direction is to be negative. Here it is anti-clockwise, anti-clockwise, this is anti-clockwise. So this is clockwise, so it is to be negative, so it is minus J. Okay, minus J you will get. That means the magnetic force is acting in this direction. So the electric force and magnetic force are acting in opposite direction. So there is a chance for the net force will be 0. That is, if F is equal to Fb, what about the velocity? V is equal to E by B. That means the charged particle moves without any deflection. Okay, this is the theory about a velocity selector and motion of a charged particle in a combined electric and magnetic field. Okay, now we will see the type 1 problem. Okay, what about the type 1? A charged particle moves in a circular path of radius 0.5 meter in a man field 0.4 Tesla. An electric field of 200 volt per meter makes the path straight. What is the charge to mass ratio? What is the meaning of the problem? They told that a charged particle is moves in a circular path. Only magnetic field is there. Okay, radius is to be given, magnetic field is to be given. Okay, how much is the radius value? The radius R is equal to 0.5 meter and the magnetic field value they have to be given as 0.4 Tesla. Okay, then what they told? If an electric field is to be applied on this, so now how much will be there? Combined of electric and magnetic field. Due to this electric field is applied, the charged particle is to be changed to a straight path. That means it is undeflected. Okay, so we will apply the velocity selector principle and we will find out the charge to mass ratio. Okay, so if the charged particle is moves in a straight, that means it is undeflected, so that electrostatic force is equal to magnetic force, that means velocity v is equal to E by B. What is E value? That is 200 divided by B value, how much? 0.4 Tesla. That I can write like this, 4 into 10 power minus 1, that is how much you will get? 200 divided by 4 is to be 50. 50 into this will goes become 500 meter per second. Okay, this is the velocity. Then we will find out the E by M ratio. What they given? The charged particle is moves in a magnetic field. The path will become circular. That means the theta. What about the theta? Theta means the angle between velocity and magnetic field is to be 90 degree. Okay, so what about the magnetic force is equal to QVB sin theta. Sin theta become 90, that is QVB. Okay, if a particle moves in a circular path, it needs a centripetal force. So this force is to be converted into centripetal force. So we can write it as QVB is equal to mv square divided by r. VV you can cancel and m come to this side. So what you get? Q by m is equal to what you get? That is V divided by RB you will get. Okay, this is the Q by m ratio. V value we already know, that is how much? 500. What about the R value? R value is to be 0.5. And what about the B value? B value is to be 0.4. This I can write like this. That is 500 into 5 into 10 power minus 1 into 4 into 10 power minus 1. You will get this 5 divided by 500. How much? 100. 100 divided by 4. 25 you will get. 25. This 10 power minus 1 will go there, become 25 into 10 power 2 you will get. Okay, this I can write like that, 2.5 into 10 power 3. What we need? A charge per mass ratio, that is coulomb per kilogram. Okay, this is the answer for the type 1 problem. Now we will see type 3. In a region, electric and magnetic field are acting in same direction. An electron is moving in the same direction. What is its change in velocity? Okay, change in velocity. So listen here. What about they are given? The electric field and magnetic field are acting in the same direction. This is the electric field and this is the magnetic field. An electron is moving in the same direction. Okay, what about the change in velocity? Okay, what about its force acting on the charged particle? This charged particle is moves in both electric and magnetic field, so it will experience Now we will see type 3. Sorry. Now we will see type 2. In a region, electric and magnetic field are acting same direction. An electron moves in same direction. velocity will be. Okay, that means in a region electric and magnetic field are acting in the same direction. Okay, I am taking this direction. In the same direction an electron is moving. What about the velocity? Okay, if a charged particle is moving combined electric and magnetic field, it will experience electric force and magnetic force. What about electric force? That is equal to Q into E. Okay, here what about the Q value? That is electron charge is minus E into E. Okay, that means electrostatic force is acting in the opposite direction. That means this is the electrostatic force direction. Okay, then what about the another force? That is magnetic force. That is equal to QVB sin theta. What is theta? Angle between V and B. Here angle between V and B is how much? That is to be 0. So it will get sin 0. We will get sin 0 value is to be 0. Okay, so this electron will experience only electrostatic force, that is in the opposite direction of the velocity. So the velocity of the particle will decrease. Okay, so velocity decreases. Okay, this the same type of problem may ask in different way, that is in this way. If the electric and magnetic field are acting in the same direction, if a charged particle is at rest, that is V is equal to 0. If a charged particle is at rest, what about the path of the charged particle? Helical, straight, circular. So they will give like this. So how will you find it? In this case also what force is acting? Only electric force is acting, because the electric force is to be acting in which direction? Along the electric field. Okay, so velocity will be start moving in that direction. Even that time also what happened? The magnetic force will be 0. So the charged particle is moves in a straight path. Okay, that is about this type. Okay, now we will see type 3. E is equal to E0J, B is equal to B0K. Electron released from rest. Which graph follows? Okay, so what they are to be given? In a region, electric and magnetic field is to be perpendicular. The electron is to be at rest. So which is the best path? Okay, so we'll do this problem. So listen here, type 3. So this electron is to be acting in electric and magnetic field. So you will experience two forces. What are the forces? Electrostatic force, that is F is equal to QE, that is here what you get? Minus E into what is E value? That is E0J. Okay. So what about the electrostatic force direction? The electrostatic force direction means acting in which direction? In the downward direction. That is in the minus y axis. If it is, this is y and this is minus y, this is x. So what about the electrostatic force? Electrostatic force is acting in this direction. Okay, so what about the velocity? The electron started to move in which direction? Electron started to move in this direction. Okay, then if the electron is started to move, the magnetic force will be experienced. Magnetic force is equal to what about? That is Q into V cross B. Q is what? Minus E into V cross B is what? V is minus Vj. I am taking us the velocity is to be V into J into B value is B0K. Okay, here what you will get? J cross K. Here J cross K is how much? That is to be I. That is I J K this way. If anti-clockwise means positive, J cross K is anti-clockwise, so I will get, but 2 minus minus become plus. So F B is equal to what will get? E B B in I direction. Okay, so the magnetic force will be started acting in which direction? This will be X. So when it will be start like this, and due to magnetic force it will be moves in a curved path. So which is the option is to be correct? This is the correct answer. Okay, this way we can solve this type 3.